So as I'm recording this, temperatures are actually a little bit above freezing at the ground, and sometimes as meteorologists we get asked that very question: how can it even be snowing when the temperatures are above freezing? Well, the reason for that is because temperatures just a little bit above the surface, even by just a few thousand feet, and certainly at the height of the clouds, they actually are below 32 degrees. And on days like today, it helps explain why the snow is often very wet. That's because it's falling from the cloud and then entering into that above freezing layer just a few thousand feet off the surface of the earth, partially melting on the way down. And when it comes to forecasting snowfall, that's actually something we as meteorologists take into account. It's something called the snow ratio, and it describes how much snow would be produced by 1 inch of liquid precipitation. It's all based on the principle that light and fluffy snow doesn't compact nearly as much as it accumulates compared to wet and heavy snow like I'm seeing right now. When temperatures at the ground are a few degrees warmer than freezing, you may have a snow ratio as small as 5:1, meaning 1 inch of liquid would translate to about 5 inches of snow. That would be very wet and heavy snow. Now, as temperatures get a little closer to freezing, that ratio gets a little closer to 10:1, so 10 inches of snow for every inch of rain. Now, if the air is well below freezing, the snow ratio can get much higher. 15:1 is our example here, but it can climb well into the 20s if conditions are right. So as we just talked about, the snow ratio, it can vary. It really depends on the air temperature throughout the entire column of the lowest atmosphere, and even the type of system or lake effect snow setup can impact that snow ratio. It's one of the nuances of snowfall forecasting, but it is very important.